Okay, so students, here we have what is the smallest number of identical batteries with EMF of 2 volts and internal resistance of 1 ohm that is necessary to use in order to achieve maximum power at the external resistance of 12 ohm. The maximum current should be 4 amperes. The battery should be connected in n parallel groups and with K battery in series for each group. Okay, so basically you have to find a total number of cells or total number of batteries that is in the circuit in order to achieve that maximum current 4 amperes and capital R is equal to 12 ohms. Now, first of all, let's try to simplify the circuit and then we can start solving it. If you try to simplify the circuit, then you can see that basically there's many batteries, so I call it K times EMF, okay? Because in series, all batteries will be added together. And then we have internal resistance. So the internal resistance is K times R divided by the N, number of rows. Now I will explain how I got this number, okay? Then we have here the capital R, then current is passing, and so on. First of all, let's find how I got total internal resistance, which is equal to KR divided by number of rows. Okay. The first case is let's look at just this side. Okay, where we have connected resistors connected in series, right? So that means we can say that R in series is equal to the each small r multiplied number of K's, which means number of internal resistance. Now we have to connect them in parallel, okay? The parallel means you have to take all this number of rows. Right now I just put only 3 rows, but it can be more than that or less than that, we don't know. Okay, so now the second part is 1 over r in parallel, or let's call it equivalent, which is equal to the 1 over rk, and since we have number of rows, the number of rows will be multiplied here and here, okay? Then we can say that it's r equivalent is equal to the rk divided by number of rows, okay? What is next? The next thing is that we know the equation when the battery and so on. The simplest will be V. The V is equal EMF minus IR. This formula is well known, okay? Now, since we have number of batteries, K, which is in a series, then what will happen? Then in that case, we can say that V is equal to the Ri is equal. Now, we have K number of cells, right? So that means K number of cells multiplied to EMF minus the I. Now the R is here R equivalent, okay? The equivalent is what we got here was RK divided by N, okay? Then let's bring it here where Ri, if you bring the right side to the left side, which is IRK over N, you will get plus IRK divided by N, which is equal K times EMF. Okay, so then we can say that I is equal to the K number of EMF and divided by the R plus RK over N. Okay. What is next? The next thing that we have to do is, in order to obtain a maximum power, in order to achieve maximum power, there is a condition where R equivalent is equal to the R. Okay, if that's the case, then you can see that R is equal KR divided by N. Okay, then let's plug the numbers. R in our case is equal to 12, is equal K over N. Now small r is equal to the 1 ohm. That means finally we will get that 12 is equal K, okay, K over N. Okay, now let me highlight this part. What is next? Okay, since we said that in order to achieve maximum power, R equivalent has to be equal to the R. Okay, what is next? So then we come back to this equation where I was equal to the K EMF divided by the R plus, now RK RK over N, right? Since we know that K over N is equal to 12, right? That means we can write down that I is equal K EMF divided, now R is, let's keep it R, multiplied K over N is 12, then R, small r is equal to 1 ohm. Okay, then we also know that our small r is equal to 12, so I can write down like K EMF divided by 2R. Okay, now from here we can find what is a K. The K is equal to the I times R. Here we have 2 and divide by EMF. Now 2I is equal to the 4 amperes, R is equal to the 12, and then EMF is equal to 2. So this 2 cancels, then we get here 48 Ks. Now so far we got that this whole thing, we have cells in one, this in a K in series we have 48. So we have 48 cells just in this whole thing. Okay, 48 cells. Now we have to find what is will be the number of rows. Okay, so how can we find it? Since we have this equation, we can say that 12 is equal K is 48 and divide by N. Okay, so the N here will be equal 48 divided by 12, so we got here 4. So number of rows is equal to the 4. Okay, so we got now K and N. Now in order to find the total number of the battery cells, what you have to do is basically N is equal K times N. Okay, you just have to multiply all this, K numbers and N numbers, where we can see that 48 multiplied to 4. So how much we will get? 48 times 4, we get 192. So we can see that we have 192 battery cells. Okay, so that's the answer.